Hi everyone, Mr. Kwan here. In this video, we're going to go over an example of Taylor series and Taylor polynomials. So let's go ahead and jump right in. This example says, consider the function f of x, which is equal to e to the power of 2x and a equals 4. Part A says, find the Taylor series of f of x centered at the given value of a. So what I like to do is I like to make a table because if you recall, our Taylor series definition is highlighted up here, and we need to find some derivatives. I like to organize this in a table, so let's go ahead and calculate some derivatives. If you want to take some time, pause the video here. I'm going to reveal the answer in just a second. All right, so here we have our derivatives, and then we have our derivatives evaluated at a equals 4. So now let's go ahead and look at our function e to the power of 2x. I've gone ahead and based off our Taylor series definition, just went in and replaced a with 4. And now I want to go ahead and write out the first few terms of my Taylor series. So by plugging in our values of n, we get this. And then if we want to condense that, we find that our Taylor series ends up being this. In part B, we want to find the radius of convergence, and we're going to do that by using the ratio test. So I want to go ahead and calculate this limit. That ends up giving us the limit as n approaches infinity of this thing where we've found a sub n plus 1 and a sub n and divided them. If we simplify the expression inside of our limit, we find that the limit as n approaches infinity is equal to 0. Therefore, by the ratio test, we have that our radius of convergence is infinity. Part C wants us to find the third degree Taylor polynomial. So we have e to the power of 2x is approximately equal to our third degree Taylor polynomial is the first 4 terms because we're looking for a cubic. And so we end up getting this cubic polynomial here that approximate our original function. Part D says use t sub 3 of x to approximate the value of e to the power of 8.2. Round your answer to 5 decimal places. Note that e to the power of 8.2 is equal to e to the power of 2 times 4.1. Therefore, what I want to do is I want to plug in 4.1 into my third degree Taylor polynomial that we found in the previous part. And I had a student in office hours earlier today ask me, is there a way that we could simplify this process on our calculator? I went ahead and I just factored out e to the power of 8 and I just threw this thing into my calculator. But there's another way that we could have gone about doing this using a summation on our calculator. So let's view how to do that. Okay, so again, we could have just punched this in term by term and then gotten our answer. Another way that we could go about doing this is I'm going to go over here to math, and then I'm going to scroll down to the option that says summation. I'm going to go ahead and press enter on that, and now we can edit the indices and the inside of our summation. Now for the purposes of this video, I'm going to have my variable be x, even though in ours we had it be n. So I'm going to go ahead and have my index be x equals and then start at 0. And because we want the third degree Taylor polynomial, we want our upper index to be 3. So now I'm going to go ahead and type in my expression here. I don't know if you can see this, but on this digital version of my graphing calculator, there's a fraction bar here, but a lot of our physical in real life graphing calculators don't have that feature. And so you could either do that if it has it, or the way that you can get the fraction bar is if you push alpha and then here F1, and then here, this is the fraction bar. So I just press enter on that and that will give me the fraction bar. So let's go ahead and type in now, we had 2 to the power of x, and then also in the numerator, we had e to the power of 8. In our denominator, we had n factorial, so I'm going to use x instead of n. The way that we get to the factorial is we press math, and then we go over to the list that says probability, and then we scroll down. In this case, it's option 4. And then I'm going to go ahead and type, remember our a value was 4.1, and then I'm going to raise this to the power of x. Let's see, there we go. And if we did this correctly, it should come out to the same value that we got earlier. And we do. This is the same value that we got. So here is another way to do this on your calculator. Is it shorter than writing out all of the terms? Well, in this scenario, we only have 4 terms, so I don't know which one is exactly faster, but this definitely would be a time saver if we were doing something like the 20th degree Taylor polynomial. This would be a lot faster because writing out 20 terms would take quite a long time. So let's go back to finishing up our example. So again, we just want to highlight that this was the same value that we got in our calculator. Part E says, how far off is your approximation of a e to the 8.2 round to 5 decimal places? So if you also throw, if you throw e to the 8.2 in your calculator, you end up getting this number rounded to 5 decimal places. And so the error or remainder, which notationally we could write r sub 3 of 4.1, is the actual value, which is this value here, minus the approximation, which we found in the previous part of the question. And if you subtract this and then take the absolute value, you end up getting that the amount that we're off, or the error, or the remainder, is 0.20696. So that concludes this video on our example of a Taylor series and Taylor polynomials. If you have any questions, leave them in the comments and I'll try to answer your questions. I hope you enjoyed watching, and we'll see you next time.